Stress. We all know the feeling, right? We talk about being stressed out all the time. But do we actually know what's going on inside our heads and our bodies when it hits? Today, we are going to peel back the layers on this thing we all go through. And we're going to start with a pretty surprising question. So, right off the bat, let's challenge a huge assumption. We're basically taught to think of stress as this monster we have to avoid, something to get rid of at all costs. But what if that's only half the story? What if some stress is actually good for us? What if it's essential for us to really perform and thrive? To get to the bottom of that, we first have to realize that not all stress is created equal. So let's break it down into its two very, very different forms. Okay, so check this out. This really shows the two faces of stress. On one side, you've got eustress. Now, this is the good stuff. Think about the butterflies you get before a big presentation or a first date, that feeling that sharpens you up. It's motivating, it gets you focused, it can even feel exciting. Then, on the other side, you've got distress. And that's the one we all know and hate. It's that crushing, overwhelming feeling that just shuts you down. It's the same basic system at work, but the results? Night and day. And this idea is captured perfectly by something called the Yerkes-Dodson law. I want you to picture an upside-down U, okay? On the far left, you've got almost no stress. You're bored, you're unmotivated, and your performance is in the gutter. On the far right, you have way too much stress. You're in that distress zone. You're anxious, you're overwhelmed, and your performance totally tanks. That sweet spot? It's right there at the very top of the curve. That's eustress. It's the perfect amount of pressure to get you in the zone and performing at your absolute best. So what's the deciding factor? What makes a deadline feel like an exciting challenge versus a crushing weight? Well, it turns out it's not the event itself. The real gatekeeper is something much, much closer to home: your own mind. This right here is the absolute core of it all. It's all about interpretation. Think about it. A traffic jam can be a minor inconvenience for one person, a chance to listen to some music. But for someone else, it's a complete meltdown. The traffic is the same for both of them. What's different is how they're thinking about it, how they're interpreting it. And that interpretation is everything. The psychologist Richard Lazarus actually broke this down into a really neat two-step process. So first, you have what he called the primary appraisal. Your brain, in a split second, asks, is this a threat? Is this bad for me? If the answer is yes, you immediately move to step two, the secondary appraisal. And this is the crucial one. Can I handle this? Do I have what it takes to cope? And your answer to that question is what really kicks off the biological response. It's the difference between seeing something as a challenge you can totally rise to and a threat that's just going to steamroll you. All right, so let's follow that signal. Let's see how that mental appraisal process actually flips the switches on your body's built-in alarm system. We're going from the mind's software, if you will, down to the brain's actual hardware. So first up, meet your amygdala. Seriously, think of this thing as the twitchy, hypersensitive smoke detector in your brain. It is built for speed, not for accuracy. It's constantly scanning for any potential danger, and it can sound a full-body alarm before your logical, conscious brain has even had a chance to figure out what's going on. Now, if the amygdala is the smoke detector, then the HP axis, well, that's the full-on building-wide sprinkler system. It stands for the hypothalamus, pituitary, and adrenal glands. It's a much slower, more sustained response. It's the system that releases that famous stress hormone, cortisol, to help you deal with a problem that isn't going away in 5 seconds. And this table just lays it all out so clearly. You've got this two-speed system. There's the fast lane, that's your sympathetic nervous system, pumping out adrenaline for that immediate fight-or-flight jolt. Then you've got the slow lane, the HPA axis, with cortisol, designed for long-term sustained vigilance. Both are absolutely critical for survival. The problem is when that slow lane turns into the only road you're ever on. And that right there brings us to the dark side of all this. What actually happens when that alarm system gets stuck in the on position? What's the price our minds and our bodies pay when that system is constantly activated? A scientist named Hans Selye mapped this out perfectly. He called it the general adaptation syndrome. It starts with the alarm stage. That's the initial shock of the stressor. Then you move into resistance, where your body is working overtime, trying to adapt and cope. But if the stress just keeps coming, you eventually hit the final stage, exhaustion. This is where your body's resources are just completely depleted. Sound familiar?
Yep.
This is the biological basis of burnout. And this burnout isn't just a feeling, it has a real physical cost. One of the most incredible findings is what chronic stress does to the hippocampus, a part of your brain that's absolutely vital for learning and memory. Being constantly flooded with cortisol can actually cause it to shrink. And that helps explain why, when you're super stressed for a long time, you feel so foggy and forgetful. It's not just in your head.
So you have to ask, why is everyone so burned out these days? Well, look no further than modern life. It feels like it's perfectly engineered to keep our stress systems firing on all cylinders. We're drowning in digital notifications, we're expected to be available 24/7, the line between work and home has all but disappeared, and social media creates this nonstop pressure to perform and compare. Our ancient biology just wasn't built for this kind of relentless, always-on pressure.
But here's the final piece of the puzzle. If we're all facing these modern pressures, why is it that some people seem to navigate it all just fine while others completely fall apart? Well, the answer seems to lie in our unique, individual blueprints for stress. The key to understanding this is a field called epigenetics, and it is a total game changer. It's this revolutionary idea that our life experiences, our environment, our diet, our behaviors, can leave little chemical marks on our DNA that literally change how our genes get used. I love this quote because it makes it so simple. Epigenetics doesn't rewrite the actual book of your DNA. Instead, think of it like a set of highlighters and sticky notes. It tells your body which sentences in that book to read really loudly, which ones to just whisper, and which ones to skip over completely. And a really powerful and honestly pretty sobering example of this in action is something called adverse childhood experiences, or ACEs. We now have strong evidence that trauma in early life can cause these epigenetic changes to the very genes that control our stress response. It's like it dials up the sensitivity knob on our stress system for the rest of our lives. This all comes together in what's called the diathesis stress model. It's almost like a simple math equation. Diathesis is just a fancy word for a pre-existing vulnerability. That could be genetic or epigenetic, like we just talked about. By itself, it might not do anything. But when you add a big stressor into the mix, that's when the vulnerability can get triggered. And that can lead to a negative outcome, like anxiety or depression. Which brings us full circle, right back to that central idea. Look, you can't change your genes, you can't erase your past. But you can work on your interpretation. You can build up your toolkit of coping strategies. So knowing everything we've talked about, knowing that your appraisal is the gatekeeper, that it's the bridge between what happens out there and how your body reacts in here, the real question is, what part of that bridge do you have the power to rebuild?